For this first one here, the house roof, basically. The triangle on the ends, we're assuming, of course, that this end over here is identical to this end and that this side is identical to this side. Otherwise, we're kind of lost. The triangles on either end are pretty simple. Those are 30 by 17 over 2, which is what? 255. And then, of course, there's 2 of them, so another 255 for the other end. These are trapezoids on the sides, and to get them, you need to see that since the ridge is 30 feet and this is 60 feet, that means there's 15 feet here and 15 feet here, which tells us that it's the same slope as the end, so that's also 17 feet there. So that trapezoid is 60 plus 30 divided by 2, the average of the bases, times that height of 17, which is, what, 765? Does that look right? Then another 765 for the other side over there. So we add those up, we've got, what, 510 and 1330 is 1840. Does that look right? See, 14, 15, yeah, you're right, 2040. 2,040 square feet. Next one over here is a countertop. We need to cover the ends. There's one on the other end that's identical. The tops and the fronts. Don't need to worry about the bottom and the back. Now what I'm going to do is this. I'm going to make it a little bit easier on myself. I am going to take this top. This is 1 inch here. What's this dimension here? 4 inches. And of course, this dimension here isn't the full 20, is it? 19. In fact, we didn't even really have to break down that 19. We just know that this and this add up to 20. Right? If you combine that with the 4 there, what that gives you is if I fold out that whole surface, I get a surface that's 24 inches by 48 inches. 24 by 48 is what? Well, it'll work either way. 152. So that's this, this, and this. Now I'll use the ends. So on the end, I'll probably do this here. This piece is 4 by 1, which is just 4. And this here is 20 by 2. Nope, it's 20 all the way back. So we get 44 times 2 because there's another end over there. That's 88 square inches. Oh, so what does that end up being? 60, 1240? My pen will work. There we go, 1,240 square inches. Now, I had mentioned, covering it in stainless steel or whatever. Let's say we have a material we're going to cover it in. That is $3.40 per square foot. How much is it going to cost to cover it? Is it going to be $3.40 times 1240? No, why not? Exactly. So 1,240 square inches. How are we going to convert that to square feet? Well, this will be 144, right? Comes out to be 8.6. 8.61 we'll go with. Or maybe we'll just go with some random stray marks on the screen. Square feet. So then the price is going to be 8.61 square feet times the 340 per square foot. $29.28. What do you think? Expensive? That's nothing. Yeah. I've seen full kitchen countertops if you want to get like a solid state, like a granite or a marble. I've seen full kitchen, not a huge kitchen, where the countertops were $4,000 or $5,000. So, yeah, she must have a fairly decent sized kitchen. Yeah, I mean, I'm talking about you could have a kitchen that's just a simple L with maybe a little island, you know, 4 or 5 grand. It's nuts. Oh, yeah. It also depends on how many seams you're willing to tolerate. You know, if you'll let them glue the rock together in a couple of spots, then it's cheaper. I mean, I've seen huge kitchens where it all comes in as one piece. Yeah, that gets sure. That gets pricey, really pricey. That's why I've seen people make the mistake of trying to cut out the kitchen sink before they carry it in. It just doesn't work. I mean, some of the countertops they have to because the machine for cutting out the sink, cutting out the stone, it just makes too much of a mess because it's a wet saw. So they have to do it outside. Then they brace the heck out of it around that sucker and they carry it in. That's usually where it's going to break is right there. Okay. Just to review then. If I give you that this washer is 1¼ inches, and that this here is 1/4 inch, find the area of that ring for me. I'll give you a minute or two and then we'll talk about it. So to do this, you got to find the big circle, subtract out the little circle. The big circle is going to have an area of pi times 5/8 squared, 0.625 squared. So 1.227 square inches. The small circle is going to have an area of pi times 3/8 squared, or 0.375 squared. There's 0.442. We subtract, we would get 0.785 square inches. Now, there is another way we could have done this. To me, it's a little awkward, but it works. What you could do, if it was easier for you, using the diameters rather than the radii, you could find the outer circumference, which is going to be pi times 1¼ right? So 3.14 times 1.25. 3.925. And the inner circumference, which is pi times 3/4, so 3.14 times 0.75, 2.355. Well, then what you would do if using those two circumferences is you'd actually use a variation of the trapezoid formula. Think of it as cutting this like right here and rolling it out. It basically becomes a trapezoid where the long side is the outer circumference, the short side is the inner circumference, and this is the 1/4 inch. So the area of this, 3.925 plus 2.355 over 2 times your 0.25. So plus 3.925 divided by 2 times 0.785. I get the same answer. So it's another way you can do it. To me, it's just so much easier to find the two areas and subtract them. It makes more sense. This one's a little less common sense. Okay, well, we got a quiz to play with.